Good afternoon friends. As you are aware, in previous couple of sessions we did work out couple of methods of measuring central tendency and couple of methods of measuring dispersion. We are going to see in today's lecture some of the applications of those two. Let us look at very first slide. This is a question wherein we have been given weights of different items collected over a period of time, and after putting all of them in classes along with their frequencies, we have got this particular frequency table. Now, we have to find out mean of this particular question. So, a very simple example, we have already worked out this type of example in previous couple of sessions. So, it would be very simple. What you would be doing first thing, the first step is what? You would be taking midpoint, is not it? Midpoint of each of these classes, is not it? So, that would be, let us term as x. So, x into f, right, multiply both of them, take summation of x and f and divide it by n, right. N is small n is sample, right, a sample size, right. So, here there are how many observations you can see 1, 2, 3, no, this is not, these are the classes. So, the n would be sum of all these frequencies and all these frequencies, right. So, that sum would be 65. So, midpoints are mentioned over here. So, this f into x 988.5. So, mean is 15.2077. So, this is a very simple example of grouped data or ungrouped data. So, this was a question on grouped data, right, because we have arranged data into classes and each class was having different frequencies, right. So, this was a case of grouped data. So, let us look at another example. So, there is a company, let us call X Distribution Company, a subsidiary of a major appliance manufacturer, is forecasting sales of its product for the next year. So, it has got 3 branches, Atlanta branch, then it has got Midwest branch and Pacific branch. So, the Atlantic branch which has got current sales of this much million is expected to achieve a sales growth of 7.25%. Similarly, this branch has got sales this much and expected to grow at this rate. Similarly, Pacific branch expected growth rate is, let us say 7.15 and sales is this. So, we have to find out what is the average rate of sales growth forecast for the next year. So, this is an example of what kind. Do we have to calculate arithmetic mean or geometric mean or some other mean? Just think for a while. So, if your answer is arithmetic mean, that is wrong answer. If it is geometric mean, that is also wrong answer, right. So, the correct answer for this question is weighted average mean, right. So, what we have to do, we have been given sales of these different branches and along with their expected growth rate, right. So, just multiply sales with their respective growth rates and take sum of these values, right, sum of these sales, sum of all these 3 sales, right, this is summation, right. So, you will get 7.46 the growth rate for the next year's sales, right. So, this was again a very simple question. The third one is calculate the average percentage increase in the bad debt expenses over this given time period. So, time period is from 210 to 2016. If this rate continues, estimate the percentage increase in bad debt for 2018. relative to 2016, right. So, this is the question. So, what we have to apply here, which mean? Arithmetic mean, weighted average mean or geometric mean? So, it would be a case of geometric mean, right. So, how many observations are there? 1, 2, 3, 4, 5, 6, 7, right. So, this is small n is equal to 7, right. So, you have got these different rates. So, we will go to previous slide. So, 0.11, 0.09, 0.075. So, this is 1.09, this is 1.09, not 1.9. Okay. So, similarly, you can, in fact, all these are, you can just multiply these values by 100, right. So, you will get percentage value. So, in this case, now all these values are all right, right. So, answer to this question is 1.09. Okay. So, the average increase rate is 9.675 per year. How did we get this? This value, right. This multiplied by 100 is 9.675% per year. The estimate bad debt expenses in 2018 is this value 1.096 and square of this, right. This is not multiplication, this square of this minus 1. So, you will get 20.29 as the answer to this particular question, right. That would be the estimated bad debt in 2018. Let us move on to next question. For the given frequency distribution, find out median class. The number of items that represents the median class. So, how many items are there? The width of the equal steps in median class, the estimated value of the median for this set of data, right, for this particular table. So, what would be the median class? How to find out median class? It is just take the summation of all the frequencies. So, this is summation of all the frequencies 300. So, this is cumulative frequency, right. So, take cumulative frequencies 300. So, the median class would be what? 300 by 2, right. So, this is 150. 150 is where? Here, right, is not it? So, this is your median class, right. Average of 150th and 151st. In fact, what you can do is, let us say if you have got odd number of data points or data set having odd numbers, then take the middle one, right. For example, if there are 3 data points 3, 4 and 5. So, this would be the median, right, is not it. So, it is basically the formula is n plus 1 by 2, right. So, this 3 plus 1 4 by 2. So, this second position would be the median. So, here also you can find out, either there will not be much difference, either you divide it by 2 or just 300 plus 1 by 2, 300.5, right. So, that is somewhere here, right. So, divided by 2, 301 by 2. So, this would be 150.5, right. So, that comes over here. So, this is your average of 150th and 151st, right. This is what I have said. Step width is, so this class this interval is 50, right, and this interval is also 50. You just take it as 50. So, 50 divided by 72 would be the average of that would be the step width and finally you want to calculate median, right. So, what you want? You want 150th point and 151st point, right. So, these are two those points. Okay. So, median would be this. A very simple question. Let us look at one more case. Here are the ages in years of the cars worked on by the village auto house last week. Compute the mode of this data set. So, how to compute? You just arrange them in ascending or descending order and find out which number has got maximum frequency, right. Compute mean of the data set, compare these two parts, compare these two answers and comment on which is the better measure of central tendency for this particular data set. So, let us calculate. So, mode is 6. Why 6? Because it is coming 3 times, 1, 2, 3, right. So, mode is 6, mean is 5.8. Now, which is better out of these two? So, because here the modal frequency is only 3, right, it is not coming for large number of times. And if you look at this data, it's fairly dispersed data, right. It's not a concentrated data, right. So, you can say that the mean is a better measure, right, because the data are reasonably symmetric, right. So, which is the final answer? Mean is the final answer here, right. Here are students' scores on a history quiz. Find the 80th percentile. So, how many data points first of all? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 10, 20, total 20 data points, right. So, we have to find out what? 80th percentile. So, 20 into 0.8, right, 16. So, 16th value would be the answer, 16th data point would be the answer, right. So, that would be 93. Yeah. In fact, what you should do is you should arrange data first of all, right. In fact, in this case this 16th position is of 93, that is why we are getting this answer. So, 93 is the answer to this question, right. Let us look at next question. Talent Limited, a Hollywood casting company, is selecting a group of extras for a movie. The ages of the first 20 men to be interviewed are these. So, these are 20, these are ages of different first 20 men. The director of the movie wants men whose ages are fairly tightly grouped around 55 years. So, those people would be selected by the director who have got age nearby 55. If now being a student of statistics, the director suggests that a standard deviation of 3 years would be acceptable. So, he is ready to even accept those men who fall in mean plus minus 3 standard deviation. Does this group of extras qualify? So, we have to take a decision over here. Does this group of extras qualify? So, what you should do first of all? It is very simple. I think you should try to find out mean first, isn't it? And then standard deviation, and then you can think of what would be the range in plus minus 3 standard deviation. So, let us look at this. So, it is a simple one. So, mean is, first of all you just take a mean which is 55.2, right. So, how did you take mean? You just the summation of all these divided by 20, right. So, this 55.2. So, mean is okay, right, 55, because the director is looking for those people who have got age 55, right. But let us look at standard deviation. For standard deviation you need to do all this calculation, right. So, standard deviation here is 3.87, right. Let us take it 3.9 for simplicity, or let us take it 4. Okay. Now, mean is 55.2 plus minus 3 standard deviation. So, this is your standard deviation, right. So, this becomes what? This is 12, right. So, this is 67.2 and this again 12 minus, so 43 minus 43.8, something like that, right. So, broadly you can say 43 to 67. Okay. So, what is the conclusion? Now, this standard deviation shows more variability than desired, because this is the variability 43 to 67. Had it been around, let us say within, let us say 51 to 59, right, just within 1 sigma limits, we would have considered this particular group, but here the variability is more, right. So, we will not consider this particular group. So, this group, what is the answer? This group does not qualify for extras, right. So, let us look at one more example. Two groups, in fact, Bessert Electronic is considering employing one of 2 training programs. So, there are 2 groups, group 1 and group 2. So, group 1 was trained by program A and group 2 was trained by program B, and the total timing of training was noted. So, for the first group, the average timing was 32.11 hours and variance was this. So, this was the mean and this was the variance. In second group, the average was this and the variance was this. So, which training program has less variability? So, this question is about what? Can you think little bit? What we have to do here? We have to find out which group has got less variability. So, how do we find out variability? So, what are different measures? What are different measures of variability? We have got range, we have got standard deviation, we have got variance and coefficient of covariation, right. So, this is basically it is a coefficient of variation is sigma by mu divided by sigma by mu into 100, right. So, it is the ratio of standard deviation to mean, right. So, this is 14.56% and coefficient of variation for program B is this. So, where variation is less? In case of program A, right. So, program A has got less variability. Let us look at some of the statements which would make your fundamentals clearer. So, you need to read theoretical part very clearly, but when you work on exercises your concepts become more clear. So, let us look at these couple of questions. The value of every observation in data set is taken into account when we calculate its median. It is true or false? It is false, right. We do not take each and every variable when we go for calculating median. Generally, we take each and every variable when we go for standard error, right. Let us look at second question. When the population is either negatively or positively skewed, it is often preferable to use the median as the best measure of location, because it always lies between mean and median. So, I will tell you once again, you got you can have a perfectly bell shaped distribution which is normal distribution, right. This is known as symmetric distribution. You may have a situation where distribution is like this. So, this is your 0 point, all these are negative values, this side all are positive values, right. So, this is a negatively skewed distribution, right. So, whenever there is a skewed distribution or non-symmetric distribution, median is the best measure. So, this is true, right. Let us look at third point. Measures of central tendency in a data set refer to the extent to which the observations are scattered. Is it? Do we measure scatteredness of the data using central tendency, or what it is? Is it the scatteredness is central tendency or something else? So, this is false, right, because central tendency is something which gets measured by mean, mode and median, right. So, this is false, right. A measure of the peakness of a distribution curve is skewness. No, it is not a skewness, it is known as kurtosis. So, this is also false. With ungrouped data, the mode is most frequently used as the measure of central tendency. No, this is false. With ungrouped data, the mode is most frequently used as measure of central tendency. No, we do not know what is the nature of the data, right, whether data are normally distributed or non-normally distributed. Sixth, if we arrange the observation in a data set from highest to lowest, the data point lying in the middle is the median of the data set. Is it correct? Isn't it? So, the the 50th percentile point is the median, right. Let us look at next one. When working with grouped data, we may compute an approximate mean by assuming that each value in given class is equal to its midpoint. Yeah, this is true, right. Seventh is true. The value most often repeated in data set is called arithmetic mean. No, it is called mode, right. So, this is false. Let us look at next one. If the curve of a certain distribution tails off towards the left end of the measuring scale on horizontal axis, the distribution is said to be negatively skewed. So, this just I just talked about, right. So, this is negative side, right. So, this tail is towards negative side. So, this is true, right. So, this negative distribution, and what would be the positive distribution? It would be like this, is not it. So, this horizontal axis will not touch the distribution, right. Next one, 10th. After grouping a set of data into number of classes, we may identify the median class as being the one that has the largest number of observation. No, this is completely false, right. Median class will not get determined by the largest number of observation, but by what? Where the cumulative frequency is equal to n plus 1 by the number of data points, right. By this is, in fact, I will show you the example, right. We just did one example like this, right. Yeah, just see. If you compare this question with that statement, then yeah, in fact, this would have been the median class, but it has happened just by chance, right. It is not necessary that this would be the median class, but this median class got determined by how? This is 300 plus 1 by 2. Okay. So, let us move on to next question. Question number 11. A mean calculated from group data always gives a good estimate of the true value, although it is seldom exact. Yeah, it is true, right. If you got large number of data, then it is possible that that data would be normal, and in most of the cases when data are normal, mean is the best measure, right. Let us look at next question. We can compute a mean for any data set once we are given its frequency distribution. Is it possible? We can compute mean of any data set once we are given its frequency distribution. Is it necessary to have frequency distribution for calculating mean? No, this false. If you have got ungrouped data, you can easily calculate mean, right. Next question, and we will look at very few questions from this particular slide. Next one is this: the mode is always found at highest point of a graph of a data distribution. Is it like that? Yeah, it is like that, isn't it? So, let us say you have got data 1, 2, 2 and 3. So, how would you get? This is 1, this 2 and this 3, right. So, this is the highest point, right. The number of elements in a population is denoted by n, small n, right. No, it is not denoted by small n, but we denote population by capital N, right. So, this false. 15th, for a data array with 50 observations, the median will be the value of the 25th observation in the array. Is it 25th observation or what? No, it would be 25 plus 1 by 2, right. So, it is 25.1, right. So, it would be the mean of 25th and 26th observation, right. So, this is false. Extreme values in data set have a strong effect on median. Is it correct? Is it correct? Actually, one of the advantages of median is that it is not affected by extreme values. So, this is 16th is false, right. The difference between the largest and smallest observation in a data set is called geometric mean. No, it is called range. So, this is false. The dispersion of a data set gives insight into reliability of the measure of central tendency. Here it is true. So, you should calculate or you should find out central tendency, but apart from central tendency, if you have got the information about variability, then it becomes a reliable measure, right. So, 18th is true, right. The standard deviation is equal to the square root of the variance. Is it correct? The standard deviation is equal to the square root of variance. Yes. So, standard deviation is equal to, so this sigma is equal to under root of what? Variance, right. Okay. So, if you have got variance, just take under root of it, it becomes standard deviation. If you have got standard deviation, just take square of it, right, it becomes variance, right. Let us take the last question for today's class. The difference between the highest and lowest observation in data set is called interquartile range. Is it? This is completely false. Why? The difference between highest and lowest observation is called range, right, not the interquartile range. So, with this let me stop here. In today's session we have seen couple of questions on those topics for which we had classes in last 2 sessions. So, in next class we will continue solving this particular exercise. Thank you very much.